So how do we do these electron dot structures? We're talking here about the valence electrons, and just as a reminder, those are the electrons in the outermost or highest principal energy level. They're the furthest from the nucleus. They're the most loosely held. So when we write a Lewis symbol, what we do is we show the valence electrons as dots around the element symbol. So let's look at oxygen and see what the Lewis symbol for oxygen would be. So we're going to use the element symbol. So for oxygen, that's an O, capital O. And then we look at the periodic table and ask ourselves, well, how many valence electrons does oxygen have? 6, because it's in group 6A. So that means we're going to draw 6 dots around the oxygen. And we do this in a pattern. It's a lot like, when you look at spots on the dice, right? They're always in the same arrangement. So you don't actually have to count the spots every time, right? You look at the pattern and you know that's 4, that's 6. And so we draw these in a similar way so that we don't have to do so much counting. So we're going to use top, bottom, right, and left. So 4 places that we can put the dots. So 6 electrons, we'll just start putting 1 on the top. Oh, let's make those a little bigger. One on the top, 1 on the right, 1 on the bottom, 1 on the left. So that's 4. And now we've got 2 more. Those are going to pair up. And so it doesn't matter exactly where you put them, but they should be in pairs. So I like things to be symmetrical. So I'll put 2 on the right and 2 on the left. So we're seeing that there's 2 electrons that are paired and there's 2 electrons that are not paired. We have electrons top, bottom, right, and left. So you could also, there's lots of different ways. You could put them like this. You could put them like that. Those are all equivalent. Okay? Any questions? Element symbol, dots around, the number of dots is the number of valence electrons. So we place these with a maximum of 2 per side, and this is just a simple way to visualize the valence electrons. So if we have 2 on each of the 4 sides, we have 8 electrons, right? 8 electrons, 8 valence electrons is called an octet. Just like when 8 people sing together, it's an octet of people. So atoms that have 8 valence electrons are particularly stable. And so this gives rise to what's called the Octet Rule. Atoms will transfer or share electrons to achieve an octet of valence electrons. What group on the periodic table has 8 valence electrons? The noble gases. Do the noble gases react very much? No, because they are very stable. They have an octet. And so what we find is that these nonmetals, elements in general, will react with each other so that all the atoms involved can have an octet of electrons. Of course, there are a few elements that are too small to form an octet. One of those is helium. Helium is the smallest noble gas. It is a noble gas. It's very unreactive. In fact, there are no known compounds of helium. It has a duet of 2 electrons, so it just has 2. But if we think about the different energy levels, the first energy level has 1 s orbital in it, and that can hold 2 electrons. And so that shell, that principal energy level, is full. And that's what makes things stable, is when we have that being full. So we'll see some exceptions to the octet rule, but in general, they're going to react to form compounds where they have 8 valence electrons. So let's stop this video.